So fundamentally, what do we need to understand about forces? Well, there's not an awful lot to it as long as we really have clarity of understanding. The first thing is that forces cause a change in motion. Now, forces can be pulls, they can be pushes, they can be either contact, which obviously by its name suggests where the force is in direct contact, or non-contact. So magnets, for example, wouldn't be in contact. Gravity is a non-contact force. And we'll cover these within the course. The other thing about forces is that a body's motion doesn't change unless an external force acts on it. So things moving at a constant speed have balanced forces. An object that's stationary has balanced forces. If I were to throw an object in space and throw an apple in space, for example, it would carry on moving at the same rate forever, or at least until it hit something, because there would be no forces acting on it whatsoever. It would just be traveling. Forces are not needed in order for things to continue having a motion, so if there's no resistance to their motion. The other thing we need to understand is that the acceleration, which we just the change in motion, is actually a relationship between the force and the mass. So if I want a large acceleration, it makes sense that I need a large force. So if I were to push something slowly, gently, there's not going to be a big change in its motion. The harder I push it, the bigger the change in its motion, the bigger the acceleration. There's an inverse relationship between mass. So if I were to push a light body, then it will have a much bigger change in motion than if I was to push something which is much heavier. So if I was trying to push a bicycle, for example, I could push a bicycle quite easily. But the change in motion, if I tried to push a train, would be very, very small because the mass is so much larger. And because the mass is large, there's a much smaller change in acceleration, much smaller acceleration.